In this video, what I'm going to do is explain the difference between physical changes and chemical changes. So when a physical change occurs, the state of matter or the appearance of the substance changes, but the identity, its composition, stays the same. Okay? And so that's key. That's something that a lot of people misunderstand when we're talking about changes of state of matter. That would be a physical change, not a chemical change. Chemical changes, what happens during a chemical change is that the original substance is going to be converted into a new substance. And so chemical changes are actually what we're going to be studying mostly this year. If we go through these, when we're talking about sugar dissolves in hot water, the process of dissolving, whenever you take a compound or an element, mostly compounds, well, always compounds, and you dissolve them into water, the sugar's identity does not change. Okay? It becomes an aqueous solution, which we'll study in this class, but it is still going to be sugar. And the way that I know that is I can actually get rid of the water by boiling away the water, and I can get my sugar back. So this is going to be a physical change and not a chemical change. Okay? If I'm talking about burning sugar in a pot, I am actually changing the identity of the sugar. It's going to be burnt. It's no longer going to be the original sugar that I started with. A nice way just to check yourself for chemical versus physical changes. For chemical changes, they tend not to be reversible. Okay, so for example, for physical changes, when we're talking about a change in state of matter, if I'm going from a solid to a liquid, that's melting. Liquid back to a solid is the reverse process which can happen, which can occur. If I dissolve sugar in water, I can get it out. I can reverse that process, so it's a physical change. If I burn sugar, I can't get that original sugar back. There's no way to get it back, so it's a chemical change. I've converted the original substance into a new substance. Okay? For a metal surface becomes dull because of continued abrasion, I'm not actually changing the identity of the substance, so this would be a physical change. Now, the whole rule as far as being able to get things back, that's why I didn't actually type it up out here, because some people might argue, well, how can I get the original metal back? It got scratched away, it got dulled by abrasion. So I agree. That's not 100%, it's not a steadfast rule, but I like to do it sometimes just to be able to check myself. But this is a physical change. I'm not actually changing the original substance into a new substance. 4, a metal surface becomes dull on exposure to air. If you're exposing metal to air and it's becoming dull, that is due to a chemical change. You're taking the original substance and you're converting it into a new substance. So this is a chemical change. Okay. Several pieces of graphite are broken into tiny pieces. I am not actually changing the identity of the substance. Instead, I'm changing its appearance by breaking it apart. So physical change. Again, my rule of reversibility, the ability to undo what I have done, for this one it doesn't hold, because if you break graphite, you can't really, you can put it back together, but you can't have it actually go back to its whole state. So don't use that as a steadfast rule about the reversibility. Just keep it as a guide for problems like sugar burning where you're not quite sure. 6, several pieces of graphite are ignited. If you are igniting something, if you're having it react with oxygen, it is going to be a chemical change because you are changing the identity of the substance. That's